but the idea is the same. We're going to continue to learn how to use these identities to simplify expressions. Why are we doing this? Because tomorrow we're going to solve equations using trig. And that's really kind of the goal of this, is to solve these equations and be able to get solutions to equations. So we're just going to jump in here with some examples. I think there's only, I don't know, don't quote me, but maybe only 3 examples. Or just bigger examples, maybe. And again, notice the directions say add or subtract and simplify. Again, the directions for this section say, like, combine the fractions, or they try to give you a hint. Eventually, it's just going to say simplify. On your test, it's just going to say simplify, because once you do this enough, you should be able to say, oh, those are fractions that are adding. How do I add fractions? I have to get a common denominator. Again, this is like a test to see if you know algebra, which is why maybe some people hate math altogether, is because it just builds on itself, right? Like, you have to know trig identities for this, but you also have to know how to add fractions and the rules for adding fractions in order to do this problem. Remember that you can't separate addition and subtraction, so if you're getting a common denominator here, secant x plus 1 cannot be separated. Secant x minus 1 cannot be separated, which means my common denominator is going to have to be this whole thing times this whole thing. You could cancel out the entire thing, but you can't separate it. Which means, the nice thing about this is, can I just multiply this fraction by this denominator and this fraction by this denominator? Like, that's how I'm going to get my common denominator. You with me on that? Like, if I had 2/3 times 3, plus 3/7, those denominators have nothing in common, so to get a common denominator, I just multiply those together, and then I say, well, I need to multiply this side by 3 and this side by 7, and then it all works out. Right? I don't even know what I just said, but these denominators have nothing in common, just like these denominators have nothing in common, although you want to say they do, but they don't. So to get a common denominator, you just multiply the denominators, and, oh, I totally screwed that up. That should be times 7, and that should be times 3. Right? Why do you guys let me do such things? Because you'd have to make this 7 over 7. You have to multiply this 3 over 3 to get your common denominator. Yes, this is where relying on calculators our whole life does us in when we get to higher math, because you can't do that on your calculator. Even the fancy calculator, you can't do that. You got to understand, to get a common denominator, you have to multiply the top and the bottom by whatever you need to get your common denominator. So for me on this one, I know my common denominator is secant x plus 1 times secant x minus 1. I got to take each factor. So multiply the top by what's missing, which means on this side, I need a secant x minus 1, and on this side, I need a secant x plus 1. You follow me on that, or not follow me? That's the algebra part. The analytic part of this chapter is the algebra step. The super great part is those are just ones up there, so that helps out a lot. But be very careful. This is a subtraction sign, which means you need to make sure you subtract all of that. So when I write this out over here, 1 times this is just secant x minus 1. But this is really like a negative 1, so that's going to become negative secant x minus 1. Questions on where I'm getting that from? That's the algebra step. Now comes the simplifying step. On the top, if I take secant x minus secant x, do you agree that those just are gone? They cancel out? Secant x minus secant x. That's why it's important to pay attention to the negative. And I'm left with negative 1 minus 1, which is negative 2. On the bottom, I got to decide, do I multiply this out or do I not multiply it out? I say we multiply it out for 2 reasons. 1, I can't cancel the top out with anything in the bottom because there's nothing left in the top but a number. And 2, you see how this is the difference of 2 squares again? Not always, but almost always, if you see a difference of 2 squares and you multiply it out, it's going to go to a Pythagorean identity because you're going to get a squared function and a 1 in there, which means almost always it's going to be a Pythagorean identity because that's going to turn out to be secant squared x minus 1. And this is where I hope did your homework yesterday. When you see this, that you're learning those identities because very soon you're going to not be able to have your notes right in front of you, that you have to know 1 plus tangent squared equals secant squared. Which means, what does secant squared minus 1 equal? Tangent squared. So this is the same as saying negative 2 over tangent squared x. I say tangent squared and I kind of leave the letter out when I say that a lot, but don't forget, like, you can never write tangent squared without a letter. I just tend to say it a lot. That's a good answer, but is that the right answer? No, because what can we do? We can bring that tangent squared up, and what does it become when you bring it up? Cotangent squared x. Common denominator is the theme of the day. Ready for another one? That's right. You don't really have to write these directions down again. It's just simplify. You can just write simplify if you want directions. But notice it does say simplify to a single trig function, and I like when the directions tell you that because it tells you that your answer should only have one trig function left in it when you're done. And so go ahead on this one and get your common denominator. Just like the last one, you're going to have to use both denominators, multiply the other one by the opposite denominator, and see if you can get started on this before I do it, of getting a common denominator. Some people in second hour say, just as you're doing this, they really want to cross these things out, right? But remember, you can only do that with multiplication. You cannot cross out cosine of x with cosine of x when there's an addition or subtraction sign there. The only way you can put addition or subtraction of fractions together is through a common denominator. So multiply each side by the other one. So that means this side needs a cosine. This side needs a 1 minus sine. So your denominator will be 1 minus sine times cosine. And again, it's a minus sign, right? So that's negative sine times 1 is negative sine. But negative sine times negative sine is positive sine squared. I think that should be your top. And on the bottom, I have 1 minus sine of x times cosine of x. Notice I didn't distribute that cosine on the bottom. And again, you might say, well, how come we multiplied the last denominator out and we didn't multiply this denominator out? Think ahead of what you want to happen. You want to be able to simplify. If we distribute this cosine, first of all, cosine times sine, is there going to be any way to make that simpler? Is there anything you can substitute in for just cosine or sine that's going to cancel the other one out? No. Another thing to think about is we want to be able to cancel stuff out. Can you cancel out addition and subtraction? Can't break it up. Can you break up multiplication? Yes. So if you can see that when you multiply it together that it's not going to cancel out, don't multiply it together, because hopefully we can get the top to simplify so we could cancel one of these things out and make it simpler. And again, it's something that more you do these, the better that you'll get at this, but I just want to kind of tell you what I think in my head as I do these problems. Anyone have a question of how I got to that point? I distribute. Negative sine times 1 is negative sine. Negative sine times negative sine is negative sine squared. Right? Like I'm taking this whole thing times this denominator. Other questions on where I'm getting this? And again, step 1 is like the algebra. algebra step. Can you get a common denominator? Step 2 is the trig identity step. Can you look at the top of that now and tell me something that I could do, something I could combine, something I could substitute in that's going to make that simpler? Because right now I can't add any of that together. What?
If you take like cosine squared of x and combine it with sine squared of x, and you get 1.
Addition and subtraction, you can move around, right? Could I say I know that cosine squared plus sine squared equals 1? Is that a true statement? Yeah, that would work, right? So I don't know how you want to write this on your note. Equals 1. So you could rewrite that as 1 minus sine of x, because cosine squared plus sine squared equals 1. And if you can get that one step, you should see some magical algebra occurring now. Because although you cannot break up addition and subtraction, if you have a 1 minus sine x in the top and a 1 minus sine x in the bottom, can you cancel that out? Which means you are left with 1 over cosine of x. And what is 1 over cosine of x? Secant of x. Again, we got to get the common denominator right. We got to multiply right. And the big key step is, can you see that? It's not the only thing you could do. You could have substituted in just for cosine squared or sine squared, and I think the algebra would eventually worked out. But anytime you see sine squared plus cosine squared, even if they're not right next to each other, if it's addition, addition is commutative, and you can switch it around and do that. Questions about that? Let's do it. It's not even as bad as this one. Look how easy this one looks.
How many?
I think this is it. What do you think about that? And then I'm going to even help you on your first homework problem. Again, there's more than one way to do this. I just try to show you the way that's easiest for me. But sometimes if you have a better way of doing this, and as long as you get the right answer and you're not breaking algebra rules, it's true. Like it's right, which means it's super fun for me to grade these tests because I have to check every one of these and your steps to make sure that that it works. So it takes me quite a while to grade these tests. But for me, when I see simplify, I think about I'd really like to be able to cancel something out, which means I'd really like the same trig functions in the top that I have in the bottom. So when I see something like number 3, and I see sine squared in the top and 1 plus cosine in the bottom, I think about, could I substitute in for either one of those and make it turn into the other one? Could I substitute something in for sine squared that would make it in terms of cosine? Could I substitute something in for 1 plus cosine that would make it in terms of sine? Sam. Right, that's our thing. So I see where you're going with this, but does 1 plus cosine of x, it's not going to fit because I have a couple problems. 1, that's not squared, right? So if it's not squared, you can't use the Pythagorean. But on those same lines, what about sine squared? Could we solve this for sine squared and have something that has cosine in it? Squared, but we could do that. See what I'm saying? So this is not Pythagorean, but I could say that sine squared equals 1 minus cosine squared? So I'm not doing any algebra here, I'm just doing substitution. Sine squared equals 1 minus cosine squared. So I can rewrite this as 1 minus cosine squared over 1 plus cosine of x. Now this is where you have to be really, really cautious with your algebra rules. Remember, you are not allowed to cancel out addition and subtraction, break up addition and subtraction. So although it looks really, really enticing here, do not cancel out a cosine with a cosine, or cancel out this 1 with this 1, because you can't do it if there's addition and subtraction. You can only cross out entire terms, which means we need to think algebraically again. Look at the top of this. Is 1 a perfect square? cosine squared a perfect square? Can we factor perfect squares minus perfect squares? Right? We factor a squared minus b squared. Factors into a minus b, a plus b. Right? So even though it's a trig function, I think we can factor that into 1 plus cosine of x and 1 minus cosine of x. And you can think about, if you FOIL that out, you get 1 minus cosine squared. And then, my favorite part, now that we have a factor, and I cross 1 plus cosine x out with 1 plus cosine x, which means I'm left with 1 minus cosine of x. And then this, Sam kind of already addressed this with the bottom of it here, but again, very common mistake is for people to say that that equals sine. It doesn't equal sine because it's not squared, right? Pythagorean, if that was 1 minus cosine squared, that would equal sine squared, right? That's not. So this is it. You can't do anything else. 1 minus cosine x. So just, it's why I can't stress enough that you need to know those identities. I hope that you learn them by doing your homework and practicing your homework, but if not, you might want to make some flashcards. Like, you need to know those Pythagorean identities right off the top of your head and not have to worry about not knowing them by the time that we have a quiz or a test. We're probably definitely going to have a quiz before spring break over this stuff, like a real quiz, not a homework quiz where you get to use your notes. So make sure that you are looking at these. So I'm going to help you with your first homework problem because people always get a little stumped by it. But this is 5-1 day 2 homework. 33, 34, 36, 38, 47, and 48. And so I'm going to help you with 33, and then 34, 36, and 38, I believe, are very similar to some the notes ones that we did. You're just getting a common denominator, and then 47 and 48, I think, are like the one we just did, where it's just like something over something, and you have to make them the same, maybe factor. So go ahead and get your paper labeled, get your book out, write down number 33, and maybe even start with the first step on 33, and we'll see where we get with this. And again, I'm sure there's more than one way to do this problem. And as long as you get the right answer and you don't break math laws, then we're good to go in here. But it's addition of fractions, which means what should step 1 be on this? Like we've been doing all day today with our fractions when we're adding or subtracting. Common denominator. So do that first. Get the common denominator, which is going to be sine squared times tangent squared. And then think about where you want to go from there, and then we'll see if we can decide together what the right step is. And I'll tell you that for this chapter, if you ever want to see my homework, there are many times that I just have scratched out stuff because I hate wasting my eraser. That I try something and it just turns into a big mess, and I just start over because it didn't work out so well. There's no magic way to start every problem, except for I feel like if you see addition and subtraction, a fraction, you should always start with the common denominator. That's a good rule of thumb. Right? I think that should be your common denominator. Multiply each by the other. Again, what happens every time is people just make up their own rules, and they do this, and then they go through and they cancel out this tangent with this tangent, and they cancel out this sine with this sine, and you're like, woohoo, it's secant squared. Do not break up addition and subtraction, right? Like, you've got to be able to turn it into multiplication. So this one people get stuck on every year, so it's why I just always started off with you. Does anybody have any ideas what we can do? can you make tangent squared into secant squared? I think if I was doing this, I think this is the place to start. Because tangent squared is already by itself. These I can't do anything with. I mean, you could change this to sine over cosine, but it doesn't cancel out. It'd been great if that was cotangent, but it doesn't. What can I rewrite secant squared as? Oh, like you're thinking Pythagorean thing? If we turn it into Pythagorean, we're going to throw in more addition into this problem. Do you agree with me? Like, it's going to be like secant, if we do tangent squared, that's going to be secant squared minus 1. If we plug in here, that's going to be 1 plus tangent squared, and we're just going to make more addition. It doesn't help if you have like terms in 2 parts. You have to have like terms in all 3 to factor. Does that make sense? Sam?
1 plus square root of x. Or did you ask what?
Secant squared is 1 plus tangent squared? That is true. What else is secant besides 1 plus tangent x? What if I wrote that as 1 over cosine squared x times sine squared x? And I'm fine if I'm just trying to get you towards the answer faster than the other way. I'm not saying it's completely wrong to do the 1 plus tangent squared or the 1 plus secant squared. I think it's going to put you on a long road to get to the answer. What happens if I put this together? What do I end up with? If I multiply that, what does that equal? I'm going to just show my steps here. Would that be plus sine squared x over cosine squared x? And what is sine squared over cosine x? Tangent x. I think that's the best route to get to the answer here. If you throw in more addition into this problem, you're not going to get a common factor. You can't, it doesn't help to factor something out of 2 things if there's still a plus something after it. You still can't cancel it out. So I think most of the time the best route is try to get to a point that you can combine things or you can factor. Addition doesn't always help. So is this going to say tangent squared x plus tangent squared x now on the top? Over sine squared x tangent squared x. And I'm showing lots of steps here. I'm okay if you go ahead and just add those together. I'm just trying to put it all together so you can see it. What would tangent squared plus tangent squared equal? Again, if you get stuck thinking about x's, what would x squared plus x squared equal? You add the numbers in front, right? So this would equal 2 tangent squared x. You add the coefficients, you don't add the exponents. You multiply, like when you multiply, you add the exponents. And look what happened. We took this addition that we couldn't separate, and we turned it into multiplication. Can I break up multiplication? Yeah. And people always get thrown off by this too. They want to cross this 2 out here, but this is like having 2 tangents up here and 2 tangents down here, or like x squared over x squared. Do you agree that I can just cross out that tangent altogether? So I'm left with 2 over sine squared x. And yet again, the theme of the day, bring it up, 2 cosecant squared x is the answer. I feel like the other problems with common denominators are very similar. Almost, one of them looks almost exactly like our notes, but I think there's an addition sign instead of a subtraction sign, which means I hope that that means you'll get to the right answer. But that one always throws people because they don't know where to go with it. And again, I didn't know where to go with it the first time either. You just try things, and that's the part that you have to get to, is being able to try things. Tomorrow we're going to take this idea and we're going to put an equation in it, put equals, which means then you have to solve equal to something, and it goes back to your unit circle and your triangles, and oh my goodness, it's going to all come together tomorrow. So again, I can't stress enough how much you need to finish your homework from yesterday, and now you only have 5 more problems to do. 34 is not that bad. Like, you should be able to start 34 right now and get it done before the bell even rings, which means then you'll only have 4 left to do. And if you have other homework from yesterday, work on that. Don't forget test corrections and retests this week. Tomorrow's Wednesday already, so Wednesday, Thursday, Friday. If you have taken a retest, I have graded it, but if you've only taken like part one of it, like no calculator, I haven't actually computed your grade, especially if I don't have your corrections, because I don't know what the old grade was. Except for Deborah, you just took yours this morning. I haven't graded yours yet, but I will.